a multiplication table, but this is what I'd like you to do. So let's start really simple. Please write down x squared minus 5x minus 24. That's as simple as it comes. Yes, that is a standard from Algebra 1, 2. What will we do? Well, everything I'm going to give you for trinomials is going to be factorable. And so I'm going to take 1 times negative 24 and ask myself what multiplies to equal negative 24 and combines to give us a negative 5. So what two numbers? This tells me they're going to be different signs. One's positive and one's negative. This tells me the larger of the two signs is going to be negative. And the combination would be negative 8 and positive 3. They multiply and they combine. So I'm writing down the A and I'm writing down the C. Remember, there's more than one way to do this, but this was the preferred way of students last year. Plus 3x and minus 8x. What's important is that you take the variable that's up top and you include it here. If you were here on Friday, we're now working with x to the 4th, and we'll get to that today as we review from Friday. Out of these two, I can factor out a 1x. 1 divided by 1 is 1. I need 2 x's. I attach one more. Positive 3 divided by 1 is positive 3. I need 1x. I already have it. Whatever's in parentheses, I'm going to copy and paste in back and ask myself, is there a value I can take times 1x? And I end up with negative 8x. The answer is negative 8. Negative 8 times 1x is negative 8x. Negative 8 times positive 3 is negative 24. So this is good. We have a front and a back. They both contain a 1x plus 3. If you simply write x plus 3, it's the same as 1x plus 3. What's in front of the first parentheses? 1x. What's in front of the second parenthesis? Negative 8. This is factored form. It's equivalent to this original expression. Look at example number 2. Example number 2. So same concepts here. Don't be frightened by the x to the 4th. I'm going to start by recognizing this is a trinomial. And so if it's factorable, 3, 8, I'm taking the a times the c. 3 times negative 4 is negative 12. What multiplies to equal negative 12 and combines to give us a negative 1? This says they're going to be different signs, and this says the larger of the two numbers will be negative. What two numbers? 3 times 4 is 12, and if they're different signs, I get a negative 12. And 3 and 4, if they're different signs, I can achieve a negative 1. Larger of the two numbers has to be negative. So I'm going to start by putting down the A and putting down the C. Putting down the A and putting down the C. Now, in this position, this is where you can make some mistakes. We're not just automatically going to put down an x. We're going to come back to what is the b term, and whatever variables with the b term is what gets attached. Whatever's with the b term gets attached. Okay, I'm underlining both. Underlining both. What can I factor of both of these? A 3x squared. What I'd be left with? Well, 3 divided by 3 is 1. I need a total of 4 x's, so I attach 2 more. Positive 3 divided by 3 is 1. I need 2 x's. I already have them. This is all a review from Friday. 1x squared plus 1. What value times 1x squared is a negative 4x squared? That would be a negative 4. Negative 4 times 1x squared is negative 4x. Negative 4 times 1 is negative 4. Okay, we've got a front half and a back half. They both contain the parenthesis 1x squared plus 1. In front of the first parenthesis is 3x squared. In front of the second parenthesis is negative 4. This leads us to what we talked about yesterday, or on Friday. Please write these down. X squared minus 1, x squared minus 9, 4x squared minus 25, 9x squared minus 1. We can apply what we learned Friday, which is the difference of squares. This is a freshman level concept, and we're going to be applying it to taking expressions and fully factoring them. So remember, perfect squares is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. I don't need to keep going. You get the concept. When the number in front is a perfect square, 1 times 1, the number in back is a perfect square. When I can take this x and evenly divide it into 2 pieces, and I have subtraction, then I'm able to quickly factor this. The 1x comes from the front, the 1's come from the back, 1's positive, 1's negative, and that's going to be the difference of squares. Freshman level concept, we reviewed it on Friday. Same thing here. Breaks into 1 and 1, breaks into 3 and 3. X and x. I have 1 x's in front, I have 3's in back, 1's positive and 1's negative. 4 is the perfect square, achieved by taking 2 times 2. 25 is achieved by taking 5 times 5, and we have an x times x. This can only happen when you have subtraction in the middle. So I have 2 x's are going to be in front, 5 is going to be in back, 1's positive and 1's negative. Very last one, 9 breaks into 3 and 3, x and 1 and 1. We can only do this again when we have subtraction. So I have 3 x's in front, 1's in back, 1's positive, and 1's negative. Now at the 3, 4 level, what you need to recognize is this can look a little different. So please write down 8x squared minus 2. Please write down 8x squared minus 2. It's natural to see an 8 and a 2 and say, well, 8 and 2 are not perfect squares. But as we talked about on Friday, the first thing we have to do is ask ourselves, can we factor out a value? What's the largest number I can factor out or divide out of 8 and also out of 2? 2. 8 divided by 2 is 4. 2 divided by 2 is 1. Now when I look at this expression inside of the parentheses, I recognize it as being a difference of squares. This breaks into 2 and 2. This breaks into x and x and into 1 and 1. So when I factor this in full, I would have 2x plus 1 and 2x minus 1. It doesn't matter which parenthesis contains the plus and which one contains the subtraction. This looks different. This goes back to what we did more than a week ago, and this is going to be the sum or difference of cubes. And so you are welcome to have your notes out with the sum or difference of cubes. Remember, this breaks into 2 times 2 times 2, x times x times x, and 1 times 1 times 1. We have 2 terms in the first parenthesis and 3 terms in the last. This is always going to be positive. Factoring is just a way to rewrite in equivalent form the original expression. So I'm taking 2x, it comes from the front, it stays from the front, and 1. And I'm going to cross those out. I've used one of each of those. If this is addition, the next place where I'm going to put a symbol has to be opposite of the original. How did I determine plus? It comes from the original expression. Okay, 2 times 2 is 4, x times x is x squared. I've taken care of the front. 1 times 1 is 1. What goes in this position? We already know that's going to be subtraction. I'm going to multiply. 2x times 1 is 2x. To review from last week. This will be our last review problem from last week, from Friday specifically. So the very first thing we're going to do is we're going to ask ourselves, is there a value that I can divide out of each one of the 3 terms? So I'm looking at the smallest term, which is 2. The only numbers that nicely divide into 2 is 1 and 2. So you're going to grab your calculator when you have a calculator later, and you'll go 48 divided by 2. And 48, it's an even number. I know it divides by 2. Same with 50. It's an even number. I know I divide it by 2. So I know I can factor it to 2. Put a 2 up front. This has 5 x's. This has 3 x's, and this has 1 x. What's the most amount of x's that I'm able to take out of all 3 terms? It has to be an equal amount. Like a lot of students want to say 5. I can take 5 from the first, but I can't take 5 from the remaining 2. I can take 3 from the first 2, but I can't take 3 from the last. The most x's we can take out would be 1x. 2 divided by 2 is 1. I need a total of 5 x's. I need 4 more. 48 divided by 2 is going to be, help me out here, 24. I need 3 x's, so I need 2 more. 50 divided by 2 is 25. I need 1x. I already have it. Now this is the trinomial that I'm focused on. This is all what we focused on Friday. So I'm forgetting about this 2x for the time being. We will write it in our final expression, but I'm going to forget about it right now. So I'm going to come off to the side, and I'm going to take a times c. 1 times negative 25 is negative 25. What multiplies to equal negative 25 and combines to give us negative 24? This tells me they're going to be different signs, and this tells me that the larger of the 2 is going to be negative. The combination would be 25 and 1, negative 25 and positive 1. They multiply and they combine. I write down the a, and by the way, a great question I often get from students is, which a do I write down, the original a or the a that's in parentheses? It's going to be the a in parentheses. And then I'm going to put down the positive 1 and the negative 25. Behind them, do I put an x? Do I put an x squared? We look back up to this trinomial inside the parentheses. It has an x squared. I'm going to attach an x squared behind the 1 and the negative 25. Underline the first 2 terms, please. Underline the first 2 terms. I can factor out a 1 and an x squared. 1 divided by 1 is 1 with an x squared. 1 divided by 1 is 1. I don't need to attach any x's. I already have 2. When I distribute, I already have 2. I copy and paste what's in back and put a little question mark in front. What value times 1x squared, what value times 1x squared is negative 25x squared? And the answer is negative 25. Negative 25, x squared. And negative 25 times 1 is negative 25. I'm feeling pretty good about this. The front and the back contain a 1x squared plus 1. In front of the first parenthesis is 1x squared. In front of the back parenthesis is a negative 25. Don't forget to bring this down. Why is this not my final answer based on what we just did for the last 2 or 3 minutes? Why is this not? Okay, is 1 a perfect square? Yes, is 1 a perfect square? So this breaks into 1 and 1, this breaks into 1 and 1, and x. I can't go any further because I don't have subtraction. This breaks into 1 and 1, this breaks into 5 and 5, this breaks into x, and I do have subtraction. So I can break this into 1x plus 5 and 1x minus 5. I bring down the 1x squared plus 1 and a 2x in front.